how are things looking for the launch?
Absolutely, sorry. So all systems are green and we are ready for liftoff.
Okay, that's scheduled in 9 minutes' time. What's going to happen after that?
Yes, the launcher lifts off towards the Nord power by 3 solid propellant stages, each one separating after finishing its job. The fairing is jettisoned once the launcher leaves the atmosphere, and after the Avum Plus upper stage is then ignited for 10 minutes, putting the launcher in an intermediate orbit. After a coast phase over the North Pole and down to East Asia, the Avum Plus ignites its engine again to reach the final targeted orbit, and the spacecraft is then separated from the launcher. The upper stage enters a new coast phase before a third boost to re-enter the atmosphere over the Indian Ocean.
Indeed, a lot to look forward to there coming up in the next 50 minutes or so. Coming up to the beginning of the synchronized sequence, the automatic sequence, that's the last 4 minutes.
Yes, Kitty, so during this time the rocket will become progressively autonomous, so computers will manage a complex sequence of operations.
Attention pour la séquence finale lanceur.
Xavier Nero getting ready to call that out.
Top H0, moins 4 minutes.
So, the range operations manager has announced the beginning of the synchronized sequence, an important moment, as you say, those final operations timed to the millisecond. Now, we have a number of control rooms on the job today. We've been focusing a lot so far on mission control and the teams here. We have another control room called launch control, and the teams there are very much dealing with everything to do with the rocket and the pad, and very much pre-launch, isn't it, Vincent?
Yes, so let's compare the rocket with an airplane. So the launch control is a bit like the cockpit. The teams here are in charge of preparing the rocket and checking it, and they monitor all these final ops before launch. And of course, after launch, the rocket goes on autopilot. There is 2 teams, one operational team, running the different operations and procedures, and one technical authorities team checking that everything goes well.
All watching eagerly there and monitoring events now in the countdown. We have another room at Colleferro, which is just south of Rome in Europe.
Yes, these are the teams from Avio, the technical authority who manufactures the rocket. So they are checking from Italy the launcher behavior, they are analyzing the data, and people from different teams such as propulsion, structure, control and so on are available and ready to jump in support in case of need.
Always good to have as many people as possible ready to jump in, as you say. And we're coming up now to 2 minutes to launch. Vega standing tall there on her pad. You can see the lightning towers, the umbilical cords. Talk us through what we're looking at.
Yes, so we can see now the launcher ready on its launch table. We can see here now the fairing on top of the launcher. So there is still electrical and ventilation links, umbilicals, yes, for electrical checks and ventilation in order to ensure the best condition inside the fairing cavity for our passenger tonight, KOMPSAT 7. So everything goes well and we are ready, fully ready for liftoff.
Everything is green, and as you say, KOMPSAT 7 up there in its first-class compartment, waiting to lift off with some nice air conditioning, keeping nice and cool. And you can see on the right-hand side, all the status panels are green. The various different systems sending their status here to these.
À tous le DDO, attention pour moins 1 minute. Top H0, moins 1 minute.
We are 1 minute to launch. We are live at the European Spaceport in French Guiana, getting ready to orbit KOMPSAT 7 for the Korea Aerospace Research Institute, CARI. Good luck, everyone.
À tous le DDO, attention pour le décompte final. 10, 9, 8, 7, 6, 5, 4, 3, 2, 1. Allumage P120, décollage. Le pilotage est calme, la propulsion est nominale. Acquisition de la télémesure par la station de Saint-Jean-du-Maroni.
Vega C and KOMPSAT 7 have started their journey. Vega C pushing itself against the gravity of our planet into the equatorial skies over the Guyana Space Center. We are heading out north over the Atlantic. Look at that. Beautiful clear skies here with some fluffy clouds. He's telling us that everything is going according to plan. And didn't you see how quickly the rocket lifted off into the sky?
Yes, very quickly. That's due to the type of the propulsion used by the launcher. So the first three stages burn solid propellant, and that gives a lot of power, and the launcher needs that power to tear itself away from Earth.
Indeed, and that's the job of the first three stages, to tear us away from gravity, which is pulling us back down. Everything's going well, he's telling us. And right now we are burning, that's the engine that you can see is actually the P20 engine. It's the engine on the first stage. It's very powerful, isn't it?
Yes, P120, so very powerful first stage, thrust at liftoff of 4,300 kilonewton. It's delivering the punch of approximately 440 tons of force, so that's a lot of energy packed into a single solid rocket motor.
Fantastic images there of the P120 burning. The next event will be the switching off of that engine. That's coming up in a few seconds' time. And we can see it there. And we have confirmation from the range operations manager that the P120 has been separated, and we've switched on the engine of the Z40. Everything is going well, so we don't need that anymore, so we can jettison it. And we are shedding weight. We are now burning the Z40, the second stage, Vincent.
Yes, the second stage called Zefiro 40, Z for Zefiro, Z40, Italian, yes, for a type of wind.
You can see on the left-hand side are the events that will be coming up during the launch, and the blue line, if you like, at the bottom is us flying into space, and he's telling us that everything is going normally. And on the bottom right-hand side of your screen is the altitude, our distance from the pad, and our speed in kilometers per second. Good shot of the fairing there, protecting our satellite.
Yes, fairing on top of the launcher, so it has a different job. So it's protecting the spacecraft against the acoustic vibration at liftoff. It's also protecting against friction when the launcher flies through the dense part of the atmosphere, and that aerodynamic friction generates a significant environment, and for instance vibrations, of course, and heat for the spacecraft. And once we exceed the atmosphere, this aerodynamic loads reduce, so we can jettison the fairing, and the principle is to avoid dragging mass that is no longer useful for the launcher mission.
Indeed, that's the name of the game, to jettison every section of the rocket as we fly, as we no longer need it. Coming up now on our next big moment, switching off of the Z40, separating the Z40.
Allumage du Z9. Tous les paramètres à bord sont normaux.
And he's confirmed we've switched the engine on the Z9. Everything's going normally.
Séparation coiffe.
And we have separated the fairing. You can see it there on the animation falling away into halves. We don't need it anymore because we've crossed the border with space, so we are outside the dense part of the atmosphere, and we don't really need it, have to worry about friction. We can see our satellite for the first time, Vincent.
Yes, the satellite for the first time on top of the launcher, so secured on top, on the adapter with a specific metallic belt called the clamp band, yes.
And quickly, just to explain here, on the top right-hand side of your screen, you can see the green line is the trajectory.
Yes, the trajectory. So in green, and in the yellow curve give us a real-time trajectory, so we can see that we are perfectly on track, in line with the prediction, and the cross is the real-time position of the launcher.
We've started something that we call Orbit Optimized Guidance Attitude. What's that?
Yes, the onboard computer continually recalculates its position. This is to make sure that it's on the right course, and if it deviates, it corrects its position and comes back to the planned trajectory. So this is clever sequence, of course, with a very good onboard computer we have on the launcher.
Looking here at these CGI images, computer-generated images, or 3D, as they are sometimes known. It's an animation. It's an animation based on what's expected to unfold in space at this very moment. And he has just announced here the pushing of the Z9, poussée du Z9 in French. So yeah. And these computer-generated images are actually a simulation. It's not the actual telemetry, is it?
Yes, a simulation. So this is 3D animation that shows the predicted behavior of the launcher, not the real behavior coming from the telemetry. So it includes, of course, the trajectory in terms of velocity, altitude, ground track, the different stages separation, and but also all the launcher maneuvers.
Séparation du Z9.
And we have separation there.
Yes.
Of the Z9. That's confirmed.
Allumage du premier boost AVOM.
And we have the first switching on of the Avon Plus upper stage engine confirmed. That's going to burn for about 9.5 minutes.
Par la station de Saint-Jean, acquisition des mesures par la station de Bermude.
And he's also confirmed that we've picked up the signal at the tracking station in Bermuda, which is a very beautiful island in the Caribbean. There you go, you can see where it is there. So Vega C checking in there and saying hello to the teams. 안녕하세요, Bermuda. So we are traveling. Have a look there on the right-hand side of your screen. Underneath the trajectory, our altitude, 247 kilometers high and climbing, our distance from the pad. And on the right-hand side,
par la station de Galliot.
Our speed, which is 7.5 kilometers per second.
Yes, already 7.5 kilometers per second, so very high speed. So it's the equivalent to 27,000 kilometers per hour. So it's 30 times faster than a commercial aircraft. So very impressive speed. Yes.
Yeah, very, very fast.
Le pilotage est calme, la propulsion est nominale.
All's going well. The piloting and propulsion are nominal. So the main propulsion phase is now over. We've got away from Earth. We have started the next phase of our journey. The Avon Plus upper stage has taken the wheel, and it has a very important job, because not only does it have to take its passenger to its drop-off point in space, but it then has to deliver it.
Yes, so we need to take KOMPSAT 7 to its orbit, so 576 kilometers above Earth, and to do that, we fire the AVOM Plus engine twice. This first time takes us to an intermediate orbit, and then later the second time will take us to what we call the injection orbit. That's the orbit where we will inject the satellite into space. And after that, KOMPSAT 7 will be able to start its new life and its important mission and tasks.
Indeed it will. And it needs to be on what we call a sun... Sun-synchronous orbit. That is a special type of orbit, north to south, nearly over the poles?
Yes, so it means the spacecraft fly over the same zone of the Earth at the same local time every day. So every time you pass over that zone, you're seeing it in the same light conditions. It means we can see the same zone in the same light day after day. So we can see how it changes over time. This is very useful for such missions, such as observing Earth and monitoring the weather.
Indeed, because these are the kinds of missions that need that constant and that continuity over time. So as we said, we are flying north. We're being tracked at the moment over the Caribbean. We'll be heading up over to the east coast of Africa, back over the North Pole, and back down over Southeast Asia. And we are, of course, tracking our rocket using telemetry. We've got ground stations along the flight path. I mean, basically, the AVM upper stage is talking to us, isn't it? It's communicating.
Indeed. The rocket sends a signal to the ground station as it flies over. They have a big dish to capture that signal, so a big antenna. That's how we know what's happening on board the rocket, and it allows us to track the flight in real time.
Indeed, we can see there, that's the Gatineau tracking station. That's in Canada. And the tracking stations actually send, and that's confirmed there, they send the data here to a hillside just outside the spaceport of the Arianespace Center, and inside these teams are the quick look telemetry teams. Very important job.
Yeah, they are receiving those real-time data from the launcher and analyzing them. So data includes the status of the engine, the trajectory, the flight control. So they compare the live data from the rocket to what has been predicted. This allows them to continuously analyze the launcher behavior and confirm that it is as expected. It's a bit like the doctor checking the health to verify that everything is fine on board. So the team in charge is located in Gallio on La Montagne des Pères, 20 kilometers from the launch pad.
La Montagne des Pères, the mountain of the fathers. We saw it back there. It's very pretty, actually. It's very beautiful. So those teams in the Quick Look telemetry building, they are actually on an internal comms loop, and they're passing the information to the range operations manager here in Mission Control. We can see him there, and he then announces confirmation of all those major events to everybody here at the spaceport, because as you can imagine, it's a big place. So everyone across the range is listening in to his announcements. Vincent, we often talk, don't we, when we're talking about tracking stations, and we talk about a rocket going in and out of visibility of a tracking station. We talk about visibility, but actually the stations, they're not actually seeing the rocket, are they? Because obviously it's deep in space. We can't see it with our own eyes. But they are sensing it, right?
Yes, Katie. When we talk about the visibility of a rocket, we are talking about how the ground stations detect and receive the signals sent by the launcher. These signals contain information related to the position, the velocity, the onboard environment, and so on. This allows us to track the accuracy of its trajectory and monitor that it's behaving as planned.
And a key factor, of course, in rocket visibility is an uninterrupted line of sight.
Yes, so the antennas at the tracking station need a line of sight to the rocket, which is unobstructed. So that's because the Earth is curved. So the rocket becomes visible only when it comes above the horizon of the station. We call this the visibility cone. So let's imagine an ice cream cone. The narrow point is on the ground and the widest part is in space. So when the rocket flies into the widest part of the cone, the station can detect it.
It's actually a little bit wider, isn't it, than an ice cream cone. It's a great analogy. The next event will be the switching off of the upper stage engine, the Avon Plus engine. That's due in a couple of minutes' time. But the engine can switch on and off a number of different times during the flight. How does it know when to do it, when to switch on and off?
Well, the Avon upper stage has a brain. It's the onboard computer, so it contains the avionics, the guidance system, and an inertia measurement unit, which tells the computer its position, its speed, and orientation. So, of course, we plan the mission well in advance on the basis of predictions and mission analysis. We program all that information into the flight software. There are sensors on the upper stage. They feed real-time information to the computer about how far it has traveled and its position in space. And when the computer detects that the upper stage is on the right orbit, it sends the command to switch the engine on or off.
He's the range operations manager telling us everything's going normally. So that information that you talked about there, the inertial measurement unit, is picking up and sensing that, of course, then is all sent down on the signal that we were talking about, the telemetry signal. That goes down to the tracking stations. It then is relayed back here to the Guyana Space Center, to the Quick Look telemetry team who we saw there earlier. And, of course, that then allows us to have all this information on the right-hand side of your screen, which is the real-time telemetry data. So we can see we're 354 kilometers above Earth and our speed 7.78 kilometers per second. Coming up now to the switching off of the Avon Plus upper stage. There we go. That's how it looks. Waiting here for confirmation from the range operations manager. And we have confirmation there that the first switch off has indeed occurred. So we are now in what we call a ballistic phase. That means there we go. That means we're traveling without propulsion. He's just told us that we've reached our orbit at the end of the first phase, and now you can see actually what's happening here. We're doing some maneuvers, aren't we? Why are we switching the engine off right now?
Well, we are on the right orbit, so we are on the intermediate orbit, which is an elliptical orbit, so with an oval shape. So if there is no other boost, we will come back to the Earth with an uncontrolled re-entry. So that's why we need a second burn at what we call the apogee, so the furthest point on the orbit to circularize the orbit.
Indeed. And if you look at the screen, you can see actually that we are now in a position vis-à-vis the sun. Kind of looks like we're pointing downwards. But actually what we're doing is we're getting ready now to start rotating as if on a spit. It's called the barbecue phase.
Yes, so at the beginning, we need first to have a certain orientation with respect to the sun, and then the launcher, as you will see, is spinned very slowly along its longitudinal axis in order to ensure the optimization of the thermal control on board. It is what we call the barbecue mode, as you said. It prevents overheating during this long coast phase, and at the end we tilt again the launcher in the good orientation, and then there will be the reignition of the upper stage engine.
Indeed, and that's all coming up. You can imagine that it's very cold when you're facing space, and it's very hot when you're facing the sun. So rotating like that is the perfect way to keep the temperatures nice and even. We're going to be coming back to you. We're going to take a short break now. We'll be back in about 16 minutes or so. And just to quickly let you know that we have a completely normal and planned gap between telemetry signals. So we're going out of the range of Gatineau. We've just heard it there. And we'll be going into the range of the next tracking station, Jeju. So we are taking a break. We're going to be back at 2:56 here in Kourou. That is 6:56 in the evening in Paris and 2:56 in the morning in Seoul. We'll see you back here then.
Attendu de la télémesure. La trajectoire est nominale, tous les paramètres à bord sont normaux. Le pilotage est calme. Tous les paramètres à bord sont normaux.
Welcome back to our YouTube live Road to Space. I'm Katie Haswell. Vincent Bourdelle is still with us from Arianespace. Thanks for being with us.
Good to be here, Katie.
You've been watching there those wonderful images of the launch of KOMPSAT 7 on board the Vega C rocket, lifting off from the pad here at the Guyana Space Centre. Talk us through what's been happening. That was about 37 minutes ago, 36 and a half, nearly 37 minutes ago.
So the Vega mission started today with the ascent of the P120, the Zefiro 40, and then the Zefiro 9. So then the Avum Plus upper stage took the lead with a first boost for nearly 10 minutes to reach the intermediate orbit. And now we are in a ballistic phase that takes us over the North Pole and then down to South Korea. And in a few minutes, the Avum Plus will reignite its engine to circularize the orbit and to reach the final orbit where KOMPSAT 7 will be delivered.
And right now, during the break, we had confirmation from the range operations manager that we have gone into the range of the tracking station at Jeju Island, which is off the coast of South Korea. It's very popular with tourists. and I think it's very easy to see why, because it's beautiful. It's known for its volcanic landscapes and very lush vegetation, wonderful climate. And it's actually home to South Korea's highest peak, a dormant volcano called Halasan. And you can just see there in the distance the little island of Udo off the coast with its white sandy beaches. It's famous for volcanic landscapes, dramatic waterfalls, lush rainforest, great for hiking. And there are plenty of food delicacies, including the sweet tangerine, which it's famous for. They grow all over the island. These stone guardians are the Dol Halubang, symbols of protection and fertility, and they're just one of several UNESCO World Heritage Sites preserving the island's history. And these are the Henyo women, continuing a centuries-old tradition of diving for seafood whilst holding their breath under the waves. That's very impressive, because they don't use oxygen tanks at all. So I think you can see there from every angle that Jeju Island offers a mix of stunning natural landscapes and cultural experiences. It's beautiful. It's a great place for a tracking station.
Yes, apparently a good time to visit is in the spring, so the cherry blossom and the weather is lovely. So another good time is the winter. You can hike on the mountain in the snow.
Sounds lovely. Let's get back to our flight, back to our journey. We are 39 minutes and 17 seconds in. The next event will be to restart the engine, but if you remember before the break, we orientated for the barbecue phase. Before we can restart our engine, we need to orientate back into the right track, back on track, don't we?
Yes, so it needs to reorient to the precise pitch, yaw and roll angles which are needed for the next burn. So it is very important to continue the journey in the right direction.
Range Operations Manager telling us there that everything is going normally and according to plan. And you can see just off the coast of South Korea, there is Jeju Island. We are literally flying over it right now, and you can see the light from the town, and the dark colour, I guess, is Mount Halasan. So that's really beautiful that we can see it from the sky. Coming up now to second ignition of the Avum upper stage.
Allumage du deuxième boost Avum.
And that is now confirmed by our Range Operations Manager. Now, he's telling us that the propulsion is nominal. Now, remember we talked about the elliptical orbit before the break, the orbit which is the shape of an oval. Well, we're switching the engine on now. You were explaining earlier to circularize it.
Yes, so we are now at the apogee of that elliptical orbit, so that is to say the furthest point of this orbit, and so we can fire the Avum Plus engine to circularize the orbit and to reach the final orbit at an altitude of 576 kilometers for the injection of KOMPSAT 7.
We mentioned earlier that the upper stage can switch its engine on and off a number of times. We didn't say how many. It's 7, I believe.
Yes, 7 times. You're right, Katie. So it means we can deliver different satellites to different orbits. Satellites, as you can imagine, have all kinds of jobs, such as telecom, monitoring Earth or scientific probes. So depending on their mission, each satellite must go to a different slot in space. So we usually need to ignite the engine a few times to get there. And also sometimes we carry several satellites on the same rocket. So we might need to deliver the first satellite, then fire up the engine and travel to the next orbit to deliver the next satellites, and so on. So it's a bit like a high-speed train dropping different passengers at different stations.
Except that our passenger today is on its high-speed train, getting off at the end of the line, its very own dedicated station. And we need to deliver KOMPSAT 7 onto exactly the right orbit in the right orientation, and to do that the upper stage will be performing a set of maneuvers. So there we have cut-off of the AVOM
Début de la manœuvre d'orientation au profit de KOMPSAT 7.
plus upper stage and beginning of the orientation maneuver for KOMPSAT 7. What does that mean?
Yes, so we are now on the separation orbit. So before we can separate the spacecraft, the launcher needs to put it in exactly the right position. So it needs to point the satellite in the right orientation and direction and orient it correctly. So this is very important so that we can inject it into exactly the correct orbit required by our customer for KOMPSAT 7.
And we're going to eject it with a set of
Le
springs.
pilotage est calme, tous les paramètres à bord sont normaux.
Yes, so the spacecraft is secure on top of the upper stage with a specific metallic belt called the clamp band. So as soon as it is released, in fact, we have the activation of simple springs that enable the separation.
Flying again, there you can see
Fin de la
another
manœuvre
shot
d'orientation au profit de KOMPSAT 7.
of Jeju Island.
Séparation KOMPSAT 7.
And we have confirmation there of separation of KOMPSAT set right over Jeju Island. South Korea has a new satellite. You can see it's moving away gently from the mothership. So that's great news. Huge congratulations to everybody and to all the teams now at KARI who are taking on their new satellite. You can see it moving away slowly.
Tous les paramètres à bord sont normaux.
And we're hearing from the range operations manager that everything is normal. So, Vincent, the teams at KARI will be going through a process to check that their satellite's in good health, right?
Yes, so the spacecraft operation engineer will now progressively take control of the spacecraft. So they will deploy solar panels, perform some health tests, and verify that everything's functioning properly on board, and so on. So there will be different operations progressively take control of the spacecraft.
Indeed, so those spacecraft teams will be focusing very hard now as they're taking on their new satellite, flying it and looking after it, checking it, as you say, making sure everything is going well. And here in the Mission Control Center, we're looking here at the customer teams, the KOMPSAT 7 teams.
Yes, they can relax a little bit now.
That's right. For some, the job is now finished as the satellite is separated, but for others, it is just beginning for the teams at KARI. And of course, the teams here at the spaceport also going to go through now the process of deorbiting the upper stage. Looking here at some smiling faces amongst the customers. And we're hoping that we will be able to speak with Caroline Arnoux, who is the head of the Ariane and Vega business unit at Arianespace. Caroline, this is fantastic news, isn't it?
Yes, incredible launch. Today by successfully proud to support an ambitious national space program. This mission marks the fourth satellite Arianespace has successfully launched for the KARI, the Korea Aerospace Research Institute. We thank our South Korea partners for their continued support and look forward to further strengthening our collaboration. I would like also to congratulate Arianespace team and our partners team for this wonderful, amazing success.
Absolutely, and a very, very well-deserved congratulations. It's been a busy year so far, and it's going to continue being a busy year, isn't it? What's next, Caroline?
For all those watching today, do stay tuned. We will be back live on December 17th for the launch of 2 Galileo satellites with Ariane 6.
Absolutely.
Thank you, and see you soon.
Yeah, thank you very much indeed, Caroline. Absolutely. We're all looking forward to that. So we're going to say goodbye now. Caroline, thank you. We're going to say goodbye now and close our program. It's been a wonderful launch. South Korea has a new satellite, and congratulations to everybody. Thank you as well very much to you for joining us.
Yes, so huge congratulations to all team who played their part in this success. So thanks to all, and thanks a lot to our Korean customer for their trust.
Indeed. And thanks to you for watching. We'll be back here for the next launch. But for now, from me, Katie Haswell.
And me, Vincent Baudel.
Goodbye.